Hello and welcome back to DevOps Fundamentals by Skillspeed. In this section, we are going to talk about Docker, and this is the first lesson, Introduction to Docker. In this lesson, we will try and understand why exactly we need Docker, the transformation of IT applications, how they used to behave 10 years back, and how they are behaving and how they are being developed today. We will have a small comparison between monolithic and microservices approach. Then we will compare hypervisor-based models versus container-based models. And then we will have a brief introduction to what exactly Docker is all about. So let's get it started. First of all, let's try and understand the software delivery process, which has changed by leaps and bounds in the last couple of years. If you talk about software delivery happening about 15-20 years back, and the kind of approach which was taken that time and what is being done today, it's completely different. And traditionally it used to be a monolithic approach which used to be taken, and the main approach was that the application was thought of as a single unit and everything was being developed together just like that, which was very tightly coupled. The major disadvantages were that the changes were very slow to be implemented. Big servers and like mainframes were needed. And anything if you want to change in your existing application, it was a very tedious task to do. And that is the reason over time, software delivery process shifted from tightly coupled to loosely coupled services. Gradually, all these services became independent and each of them could be scaled up or scaled down, which is traditionally today known as microservices architecture. So let's have a brief understanding of what exactly we mean by monolithic approach or versus microservices approach. So the first and the most important difference is that architecture is based on a single logical programming unit in case of monolithic. And as we have spoken, that everything is located within one single application block, which is in contrast with what exactly in microservices happens. Here, the architecture consists of a series of small services that work independently and communicate with each other. Now, this communication can be in various forms. The most common way of communicating is through APIs or application programming interfaces. Then in case of monolithic, if there was any change to be done, let's say you have written a piece of code to change some functionality of this application, the whole code or the whole software had to be recompiled and retested even for minor changes, which was a big drawback. Now in microservices, each service, since it is completely independent and it is loosely coupled and it can be scaled independently, so that is the reason each service can be changed independently as well. You don't have to recompile and retest the whole piece of software. You can go through this whole process of dev, test and deployment for that particular service only. You don't need to mess with any of the other code bases. And of course, since in monolithic we are talking about a single application block, it can lead, or it used to lead, to single point of failure. Even if there is a small functionality which is not working, which has broken for some or the other reason, it could result in the whole application being down. Whereas in case of microservices, since we are talking about multiple services talking to each other, and each service can be scaled up or scaled down. So let's say there is one service and for which 10 instances are running. So even if you have, let's say, 1 or 2 instances failing, you still have other instances catering to the overall application. So single point of failure is a thing of the past if you are talking about microservices architecture. And yes, we have spoken this all over again, that scaling of application becomes difficult because even minor changes takes a lot more effort in monolithic applications. Whereas in microservices, it is highly scalable. Whereas in microservices architecture, you have individual services talking to each other. So that is the reason it is highly scalable. You can scale up or scale down a single service without touching or without manipulating the other ones. One of the very big advantages of microservices architecture is that each service can be developed in a different programming language. So let's say if you have 4 different microservices which are together catering to a single piece of application, each service you can write, let's say, one in Java, one in Python, one in Ruby, and as long as they are able to talk to each other with the help of APIs, you are good to go. That was completely impossible in case of monolithic applications because the whole application had to be written in one single programming language. So continuing to the previous comparison of monolithic versus microservices, we will talk about the limitations of application deployment done in traditional way. So typically the deployment time is pretty high. The costs are huge because we are talking about multiple stakeholders joining together. We are talking about deployment happening during the weekends. You need the maintenance window. You need multiple people for a small, change request or an RFC. So all these things add to the cost, and it becomes really cumbersome to do the deployment. Similarly, resource wastage, of course, because the process was not streamlined properly, and you had to involve multiple stakeholders, multiple systems. So yes, huge wastage of resources as well. Difficult to scale. Again, we are coming back to the same problem. It was not exactly very easy to scale up or scale down if you are doing deployment in the traditional way. Difficult to migrate as well. Let's say you have to implement a new functionality, or let's say you want to move to a new tool for any other reason. It was always a really cumbersome task to do. And of course, vendor lock-in. So if you're using one single vendor for a particular task, moving from one vendor to another vendor, it was extremely difficult, and in some cases it's almost impossible. Now we will talk about virtualizations, because a containerization is again a type of virtualization. So we will talk about the traditional way of virtualization, which is hypervisor based. We are talking about VMware, KVM, Hyper-V. In VMware specifically, we are talking about ESXi servers, which are hardware level virtualization. So the major advantages of using hardware or hypervisor based virtualization is that multiple applications contained under one physical server. So you have one physical box. In that you can put a hypervisor, and then you can bring up 10 virtual machines, and each virtual machine can host a different application. And you have a very good level of isolation achieved because each application is running in a separate virtual machine. So there is no connection at all, apart from being the fact that these machines are sharing the same piece of hardware. They are completely isolated. Resource pooling became much more efficient compared to the pre-virtualization era. And it became easier to scale as well. If you have, let's say, applications, or if you need more servers, it was comparatively easy rather than procuring physical boxes and putting in more instances. Now, one level above, or one level next, if we talk about container-based model, in this model, what happens is you have isolation of applications from each other at the OS level. If you talk about the hypervisor based model, there we have the virtualization at the hardware level. In case of containers, we have the virtualization at the operating system level. And the most important advantage of a container based model is that software and dependencies are packed together. And because of this, what used to happen is earlier, if you are a developer, you need to think about whether your application is running on cloud-based models, or if it is running on on-prem data centers, or if it is running on some test machines or laptops. All these things you need to consider. But once you have container-based model, what you do is you basically package a container. Within the package, you have the software along with its dependencies. So as long as you have the capability to run the containers, it doesn't make a difference whether you are running these containers on cloud or on-prem softwares, hardwares, or you're running it on a laptop or a desktop. Doesn't make a difference at all. Now, because containers share the same OS kernel, this results in very fast booting and very fast responses from the containers whenever you want to achieve a task. And it works really well with all the major Linux and Windows servers. So if you talk about a couple of years back, or maybe a year or two before, it was not supported for Windows, but today we have extremely good support for Windows as well as Linux. So what exactly is Docker? It's an open source platform for building, shipping, and running application, of course. And most important thing to remember is Docker is one of the most popular containers out there, but it is not the only container solution. We do have a lot more of them, but Docker happens to be the most popular one, and Docker is the one which made container technology extremely popular. That credit definitely goes to Docker. So it contains multiple products and multiple tools. You have Docker Engine, you have Docker Hub, Docker Machine, Docker Swarm, Docker Compose. So we have multiple components of Docker, and there is a whole Docker ecosystem which has developed around this software. We will talk in detail about each one of them as the course progresses. If you think about Docker, it's more like an open platform for developers and system admins to build, ship, and run distributed applications. Now, it is supported by several cloud platforms today. So if you think about Amazon, if you think about Google Cloud, Rackspace, IBM, all of them, they are supporting today Docker containers. So why Docker became so popular is because it solves many of the same problems that a VM solves, a virtual machine, plus some of the other problems as well with which virtual machines could not solve. So let's take a look at what all those things are. So here are some of the things which Docker gives you, the value additions. First of all, it helps you in isolating the application dependencies. What you can do is you can create an application image and replicate it. Because of which, what happens is instead of deploying the binaries like exe or jar or var, what you're doing now is you are deploying the containers, which is a huge leap in how you deploy softwares now. You create ready to start applications. These are which are easily distributable. Right? So because you don't need to wait for the dependencies. Earlier, when you had to deploy a software, you first had to create an environment for it. But today what you're doing with the help of Docker and containers, you are shipping the environment along with the softwares as well. So the only thing which you need is a capability to run Docker containers. That's all you need. Rest all you have already taken care. Yes, it really allows very easy and very fast scaling of instances. You can go up to 10 times number of instances in just a matter of minutes. And yes, testing becomes very important, because what you gain the advantage in terms of when you work with containers is that you can test your application exactly how it is going to behave in the production environments, because what you have done inside the containers is that you have packaged all the dependencies together. So you need not worry that it might behave differently in prod environment, it might behave differently in test environment, because you're not dependent on the platform. Whatever dependencies are there, you are packaging that inside the containers along with the software. So what are some of the features of Docker? First of all, it is extremely lightweight, so minimal overhead. So CPU, input output, network, memory, all these things are very efficiently used. And that is the reason on a single piece of hardware where you could bring up 10 virtual machines, you can literally bring up hundreds of containers on the same piece of hardware. And one of the other reasons is because it is based on Linux containers, also known as LXC, which is again a very old technology. It's not exactly something new. But what Docker has done, creating these containers, Docker has made this thing very easy and very convenient for everyone. So that is again one of the reasons why suddenly we are seeing this Docker explosion, and everybody wants to use containers today. And not only that, you have some traditional ways like it uses a copy on write file system to track changes, and a lot of other things which help you optimize the overall infrastructure or overall resources which you have at your disposal. The second thing is that it is portable. So once you have your images ready, once you have your containers ready, you can actually port your containers anywhere, as long as it has the new platform or the new environment has the ability to run the containers. That's all you need. Pretty much can run on any Linux systems that supports LXC today. So Ubuntu, Red Hat, CentOS, any one of them. So it already has support for Windows, and it might be possible that in future you get support for OS X or Solaris as well. We do have some solutions in the form of Docker Toolbox, but that is not exactly working at the kernel level on the Mac and Solaris. So if you talk about the native Docker support, that is today available only with Linux and Windows. Docker is completely self-sufficient. That is one of the reasons, again, it has become so popular, because you are putting everything inside the container, whatever you need it to run, right? All the libraries, all the frameworks, application code, everything is inside the Docker container. So the container should be able to run anywhere that Docker can run, right? So as I said, the only capability you need from any of the platforms or any of the environments where you're sending your containers is that they should be able to run it. Rest all you have taken care. Here is a brief look at the architecture of Docker. We are going to talk about this in detail in the future lessons, but let's take a brief high-level overview how exactly Docker architecture looks like. So you have a server at the bottom, which is typically a physical server, which is used to host multiple virtual machines. And of course, that layer remains the same. You do need a hardware, right? Without hardware, you can't run your workloads. After that, you have the host OS, which is typically Linux. So earlier, this level was virtualization tools like hypervisors, for example, ESXi and Hyper-V used to be there, right? So as of now, that has been removed, and now you just need a host OS. Any Linux machine should be absolutely fine. Then we have the actual Docker software. Now again, you have various names for it. You have Docker Engine, Docker Host, Docker Daemon, Docker Runtime. So we have multiple names. So, but pretty much what they refer to is the Docker software itself. And then finally, on top of it, you have all the applications. Basically, all the apps are referring to the containers. Each app is inside a container. So that's it for this video. In this one, we have tried to understand the overall, the reason for the popularity of Docker. Then we tried to understand the origin, for example, why Docker came into picture, and then in the process, we understood monolithic versus microservices software development approach. And then we had a small comparison of hypervisor-based models versus container-based models. So that's it for this video. If you have any questions, feel free to raise a support ticket and we would be happy to clear all your doubts. Thank you for watching and see you.